Hello and what's up guys. In the previous video I have given you an example about the package inside ROS2, how to build it, but I didn't go into the coding work. So for this video I will begin coding with you guys, and I will begin actually with the source codes for the executables that I have created earlier. So I advise you to watch my video till the end, and of course do not forget to subscribe to my channel and to hit the notification button to stay updated. So let's dig in. Alright, so if you remember in my previous video about when I talked about the architecture of the package inside ROS2, if you remember, I have created what we called an overlay, which is a workspace, and I have created the source directory. We have two packages, the minimal publisher. I will focus in this video on the minimal publisher. And this is the source code, the source directory, and here we put like the source codes, the CPP files, and they were called like lambda.cpp and other executables. So I will recreate the lambda.cpp file, but right now I will write it with you guys. So let me open up the terminal right here, and I will use the VS Code text editor. You feel free to use any other text editor, but for now I will stick with this one. So let me initiate it, code and current directory. So as you can see, I have the source directory here. Let me create a new file and I will call it lambda.cpp. We can change the name of this file later on, but I will stick with it until we are at the level of like manipulating or changing the CMake list.txt. So let me begin writing this code. So as I told you before, you don't have to be an expert in the C++ language, but you need to be familiar with concepts like the pointer, memory allocation, the simple stuff of course, variables, methods, loops, etc. So, but I will try to explain as much as I can as we go on. So first, let me import all the libraries or the dependencies that are needed inside my code. So first, I'm gonna need chrono. And the chrono will be used for some of the things related to timing and durations, and we will see them in a moment. I will use also the memory for memory allocation in my code, because I will use what we call smart pointers, and they are very useful for the memory allocation to be efficient in using our memory. Also, I will use the string, because I will to get access to some of the methods available for the string in the string class. And finally, the most important like two header files are the RCL CPP, and this is a header file that this is very important because RCL CPP is the C++ API for ROS2, and you will use it in order to create any node, publisher, subscriber, so it's very important. Also, I will use the another header file, and this one will be called message string.hpp, and this is actually the type of the messages that I will be using to communicate, to establish the communication between the publisher and the executor and the subscriber, so in this case, this publisher that I'm creating right now will publish string messages. Now let me create the class in which actually I will define my node, my publisher node. So I will call it minimal publisher because it will be minimal, nothing fancy and complicated about it. And I need it to inherit from another class, which is the RCL-CPP. And I'm using the colons in here just to indicate a certain namespace. And this namespace will be node. And inside of this class, I will define first the constructor. Let me delete this. All right. So for the constructor, it will be called, obviously, minimal publisher. And actually, I don't know if you saw this before, but in C++, you can define in the body of the constructor the attributes of the instance that you wish to create as part of this class, in this case, minimal publisher. But another way to do it, to initialize these attributes, is not through the body, but actually through what we call an initialization list. So you put a colon, and then you put, let's say, variable 1, and you put the value inside of the parentheses, and this will be its initial value. And you put as many variables as you want. You get the idea. Now, as part of the, starting from the C++ 11 standard, a new feature was introduced which allows the user to put another constructor inside this initialization list. So in this case, if I put node in here, and let me pass the string minimal publisher, what will happen here actually is that a node will be created, and this is the constructor of this class right here, and this will be the name of the node, and this node will be the minimal publisher instance. So this is what we call the constructor delegation if you want to read more about it. Now I will continue by introducing another variable. I will call it count, and this will keep track of the loop that I will talk about it in a moment. And of course, I need to define this variable right here, the count. And actually, it will be of the type size t. And this is an unsigned integer, basically, so it's a positive or null integer. And that will be it. Okay, so let me continue with the body of my constructor. So first I will use this, obviously, to access the node right here. And I will use a pointer to a method to access it from this node instance. And this method will be create publisher. And of course, I need to pass on the template, which will specify the type of the messages to be published by this publisher. So std messages message string, and this is exactly the type that I have included in the beginning of my code. Next, I will put the name of my topic. For simplicity, I will call it topic, and then I will put an integer. Now, this integer is actually defining the quality of service, because this publisher will need to send messages to the topic, right? And from there, a certain subscriber will take these messages and process them. But sometimes there will be a lag, a delay from the subscriber side. So let's say the publisher will publish like 5 or 10 messages, but the subscriber cannot handle them with the enough speed, does not have the enough speed to handle them, to process them instantly. So these messages will be accumulated as sent from the publisher to this topic. So a queue of messages will be created, and this is actually what we call the queue size, the maximum queue size of the messages to be published to the topic. Now this number should not be that high, because you want to avoid jamming, the jamming of your system, and it shouldn't be so low because you need some flexibility in the communication. And of course, this will return what we call a shared pointer, which is a type of smart pointer. And I will call it like publisher. And obviously, I need to define this publisher, right? So let me see. Publisher. And this will be actually a shared pointer, as I said before. So RCL CPP, and this will be the publisher type. And of course, I need to define the type of the messages, which will be exactly the one here. And then it will be a shared pointer. All right. Now let me continue. And now I will define something that will something similar to a loop, let's say. So I will use this to access it, and I will use a pointer to access this method. And it is called the create wall timer. And in this case, I will specify the time from one iteration to another as 500 milliseconds. And then I will introduce the std bind. So hang on. It's okay if you don't understand it right now. I will explain it in a bit. Minimal publisher. Okay. And it will be called timer callback. This. Now, the bind method right here actually will take a function that I will define it like in a bit, which is called timer callback. And the callback function is responsible for for all the processing of the messages that are continuously sent from the publisher node to the topic. So each time the publisher node sends a certain topic, the callback function, which is timer callback in here, will be called. And I will define its body in a moment. And of course, the bind actually takes this callback function and binds it, literally binds it with this, which is the node, the node instance right here. And actually, if you read more about it, about the bind method, and I will use it later on in a slightly different manner, you can introduce some additional arguments, like a placeholder, like 1 or 2, etc. And these are actually representing the arguments that this callback function can take. But in our case, in this code, in this piece of code, I will not use any arguments with this callback function, so no need for these placeholders for now. So don't worry about them for now. And obviously, according to the API, this will give me also a shared pointer, and I will call it timer. And of course, I need to define it right here. Okay. So In this case, it will be RCL CPP of the type timer base. This will be the namespace. And of course, I will use a shared pointer too. And obviously, I will call it timer. Now, let me jump to the callback function that we called timer callback, if you remember. And obviously, it will take no arguments, as I have stated earlier, and it will return void. Now, let me define the body. First, obviously, I need to define my message, and it will be of this type, as I have specified earlier. So I will use like this to create the content of this message. And since my message needs to be flexible, so I don't want to commit to any data type, so I will put auto, and this actually will give the compiler the job to deduce the type of the message based on its content. So in this case, it will be a string. Now, if you go to the documentation of this method right here, you will see that it will create an instance with the attribute data inside of it. So I access it with the point in here, and I will assign a certain value to it. So you can put anything. So hello Robotogeddon followers. Yay. All right. And then I will put std, and here I will use the method toString, and actually this is available. I had access to this method through after including this library right here. So I will take the count that I have created earlier, and this actually will keep a track of the iterations after sending each message, as I told you earlier. Now I will use here what we call a macro, and a macro is like a higher level of abstraction version of a method. So you will have a certain method, and inside of its body you define what will happen. The macro is a similar thing, but with a slightly higher level of abstraction. So this macro right here will take, according to its API, this will refer to the node always, and I will get the logger of this node. And you need to know that inside ROS2 and ROS before it, each node has a logger that will automatically hold its name and namespace, the node's name and the node's namespace, among other information. So I will take the logger, and then I will put any message that I want. So for example, I will put publishing, and then I will use the format string. So I will put after the comma a string, and it will take place in the sentence right here. And I will take actually the message dot data, but I will not take the string data as it is. I need to use the method string, which actually will return the C version of the string, which will be like an array of characters, and this actually, the C string method will return the pointer to this array. So instead of using the C++ string here, I'm using the C version of it. And this is actually specified by the API, not me. Now this macro will display to the screen the information that I just put right here in a continuous manner each time you call the callback function and you process the message. But we don't need to print the message. The main purpose, the main goal is to publish actually this message to the topic. So for this I will use the publisher pointer that I have created earlier, and I will get access to the method publish inside of it, and I will pass the message to this method. Now, one thing that I forgot is this expression. Using namespace std chrono literals, and this will actually allow me to use the 500 millisecond right here duration inside my wall timer. So without this expression I cannot write 500 millisecond. It will not be understood by the system. Now we are done with everything. So as part of any code, you will need to have the main method. Okay, so after creating this node, you need to activate it, right? In order to do that, first you need to use RCL CPP init, and you pass on argc and argv. But here argc and argv will be the default values. I think there will be 0 and null respectively. You don't need to worry about them, because like these values are passed from the terminal when you run the node using the ROS2 run command from the terminal. But obviously when I run the node, I will not enter any commands from the terminal, any arguments. So these will be the default values, and the node will be initiated like in a default manner. So you don't need to worry about this thing for the moment. RCL CPP and spin. I need to spin this node that I have just created as part of the minimal publisher class. So I will create a shared pointer. I will use make shared method, and I will specify the name of the class in which I have created my node. And I will pass it to the spin so the node can be activated, obviously. And finally, I need to call the RCL CPP shutdown method. And you can say that the shutdown is responsible for cleaning everything after you finalize the activation of the node using Ctrl+C in your terminal, let's say, to clear all the data, free all the memory, sorry. So it's very essential to be used. It's a good practice. And obviously return 0 to make sure that the main body has been executed successfully. Now I will save everything in here, and we are done basically. Now, as usual, let me go to the source directory, and it will be in here. So let me open the terminal. So I'm now in the overlay directory. So I will use Culkin build to build my packages. And I'm interested right now in the Lambda publisher. Okay, apparently I have an error. So let me check. Source, minimal publisher, and code. Okay, what's wrong? There's something wrong in here. Okay, alright, sorry about that. Apparently I have put the main method inside my class. Obviously I should put it outside. So let me put the braces and here. And do we have any other issues? Okay, so the inheritance here should be public. It's a specific type of inheritance, but I don't think it will give any issue. Okay, let me try now. So let me go ahead, Colkin build. Okay, so I have like a small issue because like I have put the other executables inside my CMake list, but I deleted them from the source directory, so I should put them back. So let me do that quickly. But later on we will like modify the CMake list.txt file, so don't worry about it. So let me take those two and put them right here. And now we should be fine. Okay, finally things worked out. Thanks God. Alright, so let me open like a new terminal, but let me go to the install directory. Inside like here, okay, where we have the local setup.bash, if you remember. Let me open a new terminal window. This is very important, a new terminal window. And let me source this. And local setup.bash. So now I can use ROS2 run. This was the name of the package. So I will copy it. And then it was called publisher lambda, if I'm not wrong. And here we go. So as you can see, this data in here, info along with the name of the node, as I have specified in the node constructor, if you remember. These are provided by the RCLCPP info macro, if you remember, after having access to the loggers of the node. And this is publishing, hello Robotics, and then followers. And obviously the counter is not being incremented. So let me show you why. I believe I didn't like put a ++. Yeah, right here. So if you like put the incremental symbol in here, it will be incremented each time we call it. So let me repeat that quickly. So if you apply any modification, this is not Python, this is the C++ language, so you need to build again. And you should run it. And obviously it will be incremented each time the message is being published. Now in the next video I will create a subscriber node. It will be similar to the publisher node, no like major differences. So I will go over it briefly, and then we can start by like writing our CMake list.txt. So I hope you enjoyed this video today, and I hope to see you guys later on.